we go. All right, for today, we're going to talk about infinite geometric series. Let's talk about infinite things. Imagine for a moment that you started reading right now, 1 word per second, and you just kept reading for the 1 word per second for the rest of your life. Like all the way until you were 90, and you never even took a break to go to the bathroom, eat, drink water. I mean, obviously you couldn't do that, but I mean, maybe, you can't really sleep and read at the same time, so maybe some of you tried, but infinite, it's kind of a weird concept. That would not be, it would be the rest of your life, but would it be an infinite amount of words? Not even close. No. What if you picked up every grain of sand that was on a beach or under the water in a lake or ocean, and you counted all of them? No. That's a finite number. There's a number of grains of sand. And you might be like, but it's growing. That's true. It's growing. But if as soon as it grows, because one little rock breaks into a small enough piece to be called a grain of sand, then there's another rock, there's another grain of sand that is actually degraded to be so small that you wouldn't count it as a grain of sand. I mean, it's kind of crazy when you start talking about things like infinity. All right, so here's a couple rules you have to understand in math. If I say that the answer is infinity, infinity is not a place you can get to. So if I say, does this function have a maximum? And you say, yeah, the maximum is, it'll go to infinity. The answer is no, it actually doesn't have a maximum because it's going to keep on going. All right, so if I wanted to add up a geometric series, I'm going to give you a geometric series. 2, and then I triple it, and it's 6, and I triple it, and it's 18, comma, dot, dot, dot. If I wanted to keep doing that an infinite number of times, would the last number be infinity? Nope. Because there wouldn't be a last number, right? And how about this? What if I added up all of the numbers I ever created? Would that be infinity? No. So does this add up to infinity? No. You just can't add it up. You get what I'm saying? So it's important to get the distinction between there is no answer or the answer is infinity. All right. So the thing that's kind of strange, though, is there is a way to add up a geometric sequence, but only if the R value is a certain thing. All right, so that was an R value of what? How do I even tell? You times by what to get to 6? Well, you can take 6 divided by the 2, and you would get 3, so R must be 3. True or false? True, the R is 3. Okay. So what kind of R value do you think you'd have to have in order for you to be able to add up an infinite list of things? Now, first of all, some of you would have said that there is no way to add up an infinite list of things, and I get that. I totally get that. But I'm going to prove to you in a minute that if we couldn't add up an infinite number of things and get a finite number, you'd never be able to get out the door. You'd never be able to leave this classroom unless you could add up an infinite set, an infinite series. Okay, so R can't be something like 2. Let's play around with some other options. What are the other options besides numbers like 2, 3, 4? I mean, what else could you use for an R? 0. All right, what if R is 0? And I start with 10, and what if R is 0? What's the next number? 0. And the next number? Okay, well, is that really a R value that, well, I don't know. It's an R value. R is 0. But am I adding up an infinite? Yeah, I guess I am. I'm adding up a whole bunch of zeros. Okay, so yeah, it kind of works. All right, how about an R value that's negative? Let's take 10 and use an R value of -2. Would everybody please find the next 3 terms? If R is -2. I'm going to pause for a second and give that a try. If R is -2. Okay, so if r is negative 2, then you'd go times negative 2, and you get negative 20. And then I times by negative 2, and then I get positive 40. And it's going to flip-flop back and forth like that. 10, negative 20, positive 40, negative, what's next? 80. Do you feel like that one could add up to some specific number, like 100? Even though you're going to have to keep on adding another number, and then another number, and then another number? Yes?
If you did -1, wouldn't it be 0?
Okay, wait. Talking about changing r, right? So let's stick with this example. I'm just trying to determine if r is negative 2, r equals negative 2. Do we figure out, does it seem like that should add up to something? No, that one won't add up to something. It won't. Because as soon as you think you know what it adds up to, well, then wouldn't you add just one more term on? And then it would change it. Okay, all right, so the concept of adding up an infinite number of things and getting an answer is really difficult. Pausing. So we've tried r equals negative 2. That doesn't seem like it's going to give us a way to add something up. What did you want to try? Negative 1? All right. So if we start with 10, and then we times by negative 1, what would the next term be? And then you times by negative 1, what would the next term be? All right. And then let's say you got this answer,
So it's 10 or 0.
but then if you add on one more thing, isn't it going to change to something else?
So it's 10 or 0.
So I would agree it's either 10 or 0. That's interesting. It's one or the other. And that's something you'll study in calculus. Okay. All right. So that does not appear to add up to one simple answer. All right. So who's got an r value that we haven't tried yet that's kind of different than the others? Yes?
Infinity.
If r is infinity, that's an interesting thought. You cannot multiply by infinity because that implies infinity is a number. So good try, though. We are kind of exploring weird situations. But nope, r can't be infinity. All right, I'll give you this hint. It's not a negative number. But what kind of numbers haven't we tried yet? It's weird that this kind of number escapes people, but it does. So that's why I'm talking about it a lot, so that you'll get this. You'll get this on the test. Decimals or fractions, and decimals would be between 0 and 1. And fractions, again, a fraction, it kind of depends. The fraction 2 over 1 is a fraction, but yet it's not the kind of fraction you want. So you want to say an r value that's between 0 and 1. So, for example, 1/2. So let's start with a number like 10. And let's cut it in half, and what is that? 5. And let's cut it in half, what's that? 2.5. Can you do it one more time? Cut it in half? 1.25, very good. And it's going to get to be a pain after that, so we'll stop. But do you get, we are multiplying by 1/2 each time. Our value, that's a decimal between 0 and 1. Okay, so doesn't it seem like that couldn't add up to something specific? I mean, you keep on adding something, right? But this does. This list of numbers will add up to something finite. And if that doesn't bother you, then you aren't like understanding it. Because, or you're understanding it incredibly well. But if you have an infinite number of things and they add up to something finite, that's weird. Because shouldn't you be able to just add one more and then it would like one more term and then it would change a little bit? All right, let me give you the example that's in the real world that will help you understand that this has to be true. From me to the door, that's about 8 feet. Would you agree that to get from where I am right now to the door, I have to get halfway to the door first? And that's going to take some amount of time, right? Then do you get, that would be 4 feet. And that's my first term is how far did I move? I moved 4 feet. And then after that, I've gotten halfway to the door, and now what? I'm going to have to move halfway to the door again. And isn't that going to take some amount of time? And I think some of you are catching on, so that's an infinite. You could keep going infinitely like that, right? Okay, so then 4 is 2 is 1 is 1/2, ... And that can be added up You know what it'll add up to? 8. Because I have to get out the door. And I was 8 feet away. But yet, it's an infinite series. This keeps going. And at the end, aren't you still adding something when somebody says, stop, it adds up to 8? That's the weird part. Isn't it taking some amount of time to take that last little, like half of a half of a half of a half? Yeah, but yet all of those amounts of time add up to something too. Same exact idea. Okay, how long does it take me from get to here to the door? Well, this long. There, I got there. And that amount of time, well, you could cut it up into halves and halves and halves and have an infinite series, but as long as your R value is between 0 and 1, you can add these up. And we knew that one added up to 8. Anybody want to take a guess at what this one would add up to? 20. Very good. Now I'm going to change the question a little bit. Let's say I'm 9 feet from the door, a little further from the door. Okay. And now I go 1/3 of the way to the door. And then I go 1/3 of that. And then I go 1/3 of that. And then I go 1/3 of that. But what do you think they all add up to? 9. I'm 9 feet from the door. Okay, so what's my first term? My first term isn't 9. My first term is how far I'd walk, which would be 1/3 of the way there, which is 3. Comma, what's the next one? 1/3 of that, which is what? 1. And then I do another third of that, which is 1/3. And notice my R value is 1/3. Yes?
If you walk 1/3 to the door, would you technically have 6 feet left?
Would you agree that if I'm 9 feet away and I go about 3 feet, that's going to be about this, and I'm 6 feet away from the door? I agree. But I'm adding up the total I have gone. So far I've gone 3. You know what I'm saying? And the next time I go from here to the door, now I'm going to do 1/3 of the way to the door. You get what I'm saying?
Yeah.
All right. And I'm going to go 1/3 of the way, and I just keep on adding up those little pieces, and that is going to add up to 9. What? Well, there's a formula for this. And I want to draw your attention to it. It's on this slide right here. A convergent series. It converges to, when I say, like to say in the real world, it equals. Like, I am going to go that 8 feet to get to the door. It's going to add up to 8. It doesn't just converge to 8. I mean, that's the way we say it. But here's the formula that you have to be able to use. A over 1 minus R. So let's use it. A over 1 minus R. So I'm going to start with 12. And then we're going to go 1/4 of the way to the door, so to speak. So I'm going to do 12 is my first term. And then I'm going to do times 1/4. So what's the next one? 3. And then I'm going to times by 1/4. 3/4. And then I'm going to times by 1/4. 3/16. Dot, dot, dot. There's my little sequence of numbers that I could call a series. But since it goes on forever, it's an infinite series. But since I have a formula for that, I like to say S sub infinity. I know it said S sub n, but who's got a short-term memory? What was that again? A over 1 minus R. So what's A? A is 12 over 1 minus R. What was R? 1/4. 1 minus 1/4. So then this is 12 over 3/4. And don't forget that means changing it from divided by 3/4 to 12 times by what? 4/3. Then if you can factor it, you should. I'm going to take my 12, factor it into 4 times 3. Then I can cancel these. And so my answer is 16. That's what that adds up to. But I get, it should bother you a little bit that you're adding up all these infinite little pieces and it comes out to a whole number. All right, so let me give you another one. And this fried some brain cells last hour. Let's see if you can get this one. if I do the dot, 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 that implies it goes on forever. So this is an infinite series. Add it up. Pause for a second while you give that a try. I hope somebody in here figured out something. Who feels like they made a like breakthrough on this one? What do you think?
I mean, it could be geometric or arithmetic.
Interesting. I never intended to change topics. We've been on geometric the whole time. This is geometric.
Okay.
But I get you that I never said. So now that I'm saying it, it's geometric. What's going on? What do you think? So what's the problem with that? And first of all, how did you get the common ratio of 4/3? Some kids wouldn't get that. You took that divided by that. 1/4 divided by 3/16, which is like 1/4 times 16 over 3, changing it to 4 times 4, canceling, 4/3. You're right. So what? Do I stick it in the formula? I think that's what a lot of people did. But you remember me saying, what did R have to be in order for this formula to work? Between 0 and 1. So this formula does not apply. You can't just blindly stick in the 4/3 into the formula. Because isn't this thing increasing every time? You may not have noticed because they're fractions, but when you go from 3/16 to 1/4, 1/4 is actually like 4/16, right? It went up a little bit. And so it's just going to keep going up, 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 up. Things that go up, 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 they can't be added up. Now, mathematically, you can't just say that as like a proof, but you can say that this formula, S sub infinity is equal to A over 1 minus R, only works when R is between 0 and 1. You can't just use the more friendly, but things that go up can't be added up. That's a true concept, but that's not mathematically why. This formula only works when R is between 0 and 1. So since that's bigger than 1, this formula doesn't work anymore. Okay, and one more just to clarify, arithmetic, that's the kind where you add something each time or subtract something each time. Those cannot be added up. Because if I'm giving you like watermelons, okay, I keep on giving you another watermelon, keep giving you another watermelon, how many are you going to have eventually? Well, you can't say like, eventually I'll have 63 watermelons, period. No, because then I'll give you another watermelon. But that's why it's so annoying that I can say that if I just keep going halfway to the door, halfway to the door, halfway to the door, it seems like there's an infinite number of things there. Why should that add up to something exact? Taking an infinite number of things and having it add up to something exact. So strange. All right, but it's true or you wouldn't get out the door. All right, I'll give you one more example that's going to annoy some of you. And I enjoy that. All right. Would you please start with n is equal to 0.9 repeating? Now, would you please multiply both sides by 10? Multiply both sides of this equation by 10. It's an equation, right? I use red. Times 10 times 10. 10n equals, well, how do you times something like a decimal by 10? Oh yeah, you just move the decimal over. So it's 9.9 repeating. Okay, now, would you agree I can subtract anything I want as long as I do it to both sides? Okay, I want you to subtract 0.9 repeating. But wait, that's going to be kind of clunky on this side. And since 0.9 repeating is the same thing as n, it says so right here, that's a given, then I'm going to subtract n on this side. It's the same as subtracting 0.9 repeating. Oh, there, you saw the bitter taste of that. What? Why is that a bad why is that a bad thing? Nine n equals 9. So n must equal 1. Isn't it kind of the same thing? a whole bunch of little tiny parts that end up adding up to something exact. I don't just get close to the door, I get exactly 8 feet to the door when I add up an infinite number of little halves and parts. And if I'm adding up a whole bunch of 0.99999, eventually aren't you adding like 0.00009? Yeah. Aren't you eventually adding 0.00000, like 100,000 zeros, and then a 9? Yep. But it adds up to something exact, and that bothers you. I know. It seems like it can't. All right, I'm going to give you a couple more things to make your brain hurt. What's 1/3? 0.3 repeating. What's 2/3? 0.6 repeating. Let's add them up. 1/3 plus 2/3 is 3/3. 0.3 repeating, 0.6 repeating, 0.9 repeating. Oh, wait a minute. It's 1 again. All right. I have one more. This one is a question for the ACT, people that care about your ACT score. You have to know what a rational number is because they'll say, let n be a rational number. Well, and you have to know what does that mean? That just mean a normal number? No. What's a rational number? A rational number can be written as a fraction. Okay. So, if a rational number can be written as a fraction, next step, like 0.7 repeating, is that a rational number? Can it be written as a fraction? I know you don't want to agree to anything that I'm saying because it'll eventually lead to that 0.9 repeating is 1. But anyway, would you agree that 0.7 repeating is a fraction? Anybody know it? 7/9. Very good. All right. How about 0.8 repeating? What's that? 8/9. How about 0.9 repeating? I don't want to say it. But I think y'all know it must be 9/9. And if you're like, well, okay, it just doesn't work in that case. Okay, fine. But then how about this? If all repeating decimals are rational, and rationals can be written as a fraction, then 0.9 repeating has to be able to be written as a fraction. Even other weird repeating decimals, like 0.253 repeating, that can be written as a fraction. It's 253, anybody know it? Over 999. Anything that's a repeating decimal can be written as a fraction. So what's 0.9 repeating? Must be 9/9. So therefore, 0.9 repeating has to be able to be written as a fraction because it's a rational number. And so what is the fraction if it isn't 9/9? I don't know, something else. Okay. It's 1. And then people will usually say, so if I wrote 1.9 repeating on the test instead of 2, you'd probably mark it wrong. And I'd be like, nope, that's a really smart kid just showing that they're smart. I'll warn you, your calculus teacher might not have as much fun with that as I would. 1.9 repeating, they might say, well, I didn't think you really knew what you were talking about, but you could go prove it to them and they'd probably have to give you that point. Because 0.9 repeating is 1. And I know you might not want to argue with your calculus teacher, but these are some pretty good proofs, especially the one about aren't all repeating decimals, aren't those all rational numbers? You could walk them down that path. And they'd be like, well, yeah. And aren't rational numbers supposed to be able to be written as fractions? Well, yeah. So 0.9 repeating is got to be able to be written as a fraction, right? So what is it? It's 1. And therefore, 0.9 repeating is 1. It's not just really close. All right. I know that should kind of bother you a little bit, but when you get to have something proven to you, you eventually have to either accept it or reject it. And some of you guys are going to reject my reality and substitute your own. And that's fine. But, when the first person came out and said, hey, by the way, the earth, it's not flat. There really was a violent reaction to that. Like violent. Like they wanted to kill that guy. They kicked him out of his church. And he was in big trouble in the intellectual circles because everybody knows the earth is flat. So anyway, you don't want to be the person who's arguing just because I always thought it was the other way around. No, the people arguing that everybody knows that it's flat.
Do you think it is?
No, I'm not a flat earther. No. I know, there's still a few. It's really scary. And then they have to believe somehow that every time like somebody goes up into outer space, or even in a plane, have you ever been high enough to be able to see a slight curvature?
I don't look out the window.
And if you go up in like all the pictures that are taken by these balloons that get launched, maybe you haven't seen these either, but you can launch a weather balloon and just let it go like super high, and then have your GoPro on it. Now, by the way, dangerous. Why? Because planes are flying around up there, and you could have it go right into a plane engine. And anyway, but some people did it, and their GoPro. Eventually, the balloon broke, and what happens? The GoPro comes back down again, right? And they found the GoPro, and they were able to bring back the footage of it. It's pretty cool. And guess what? The Earth was round, and it wasn't flat. Okay. But that must be a fake. That was the government trying to put you in the dark, because they faked that whole thing, just like the moon landing. Anyway.
That'd be so.
All right. So let's get to your homework for tonight.
That would be so sad.
Your homework for tonight is asking you, ooh, it's an infinity symbol. It's probably about infinite stuff. But there's also a little bit of review of yesterday. And let's see if you remember how to do that part. So your assignment is to do those problems, all the one on the red page. And number 2 of it is about an arithmetic series. Could that even be about adding up an infinite number of terms? No, because that doesn't work for arithmetic. All right, so this must be a review of yesterday. So let's jump in and see if we can do this one. All right, I'm going to call on different people to try to get some breakthroughs on this. Row 3, person 2, that's you. Or were you just up singing all night so you didn't have a chance to learn any of that stuff yesterday? I know you were singing, and it was very good, by the way. All right, so it has a first term of 2. How about we make a list of them? 2, comma, and then, do we know the second one? No. Third one? No. Fourth one? No. But we do know the 5th one, and it's 30. Now, I hope you remember me saying this. This unit, it's all about the formulas. Okay, you can't just try to brute force these things. Yes, I know, you could. You could look at this and go, ooh, it's arithmetic, and so I can know they're adding something each time, and you could brute force figure out what it is. But don't, because the ones we give you on the test, it'll be too hard to do that. You got to use the formulas. So what's a formula that tells me the 5th term? All right, who can be the formula sheet? I could be the formula sheet because I have them memorized. Anybody else think they got this formula? Mr. H.
Okay, well, a sub 5.
A sub
equals
5.
A sub 0.
Just give me the pure form of the formula to start with. Keep going.
So a sub n equals a sub 0.
Okay,
Plus d times 20
you are correct. And you guys could have looked that up on your sheet. Now, the sheet wouldn't have told you which was the right formula, but I hope you would have figured out it's under the arithmetic category. And, all right, please focus and not on that. Focus on your iPad. Okay, so what's the a sub 0 now? Let's put the numbers in. You be put in numbers person, Miss W. What goes where?
A sub 0 would be
2 plus, what was the d? Do we know the d? No, so we put d. And then what's the n minus 1 part? Well, let's put in a number like here too. Let's put in the 5th term there. So do you get how that's a sub 5, which is 30? And then we'll know what n we're on. You know what I'm saying? So what's the n?
5.
Yep. So 5 minus 1. So then this is really 30 equals 2 plus d times 4. And I bet you all could solve that. Right? And now I know what d is. There. What would have been trickier is if I didn't give you the first term, and if I had instead given you like the second term. I'm going to do one like that off to the side just to show you. Let's say I gave you the second term is 8, and the third term is negative 12. And if it's arithmetic, you'd have to set up two equations. And again, I know you could guess and check, but don't. So what's the equation for that one? I'm going to pause for a second and have everybody try to write an equation for that one. And then there's going to be a separate equation for that one. And then you'll have two equations and two variables, and you could solve it. So just write me the equation for the negative 12. Hint, it's the fourth term. And I know you don't know the first one, so you'll have to leave it as a sub 0. Pausing for a second. All right, so I hope you said the fourth term would be negative 12 equals, and then you go a sub 0, which we don't know, so I put a sub 0, plus d, which I don't know, times n minus 1. I do know that. What's the n in this case? 4 minus 1. So that's a 3 right there. And then how about this equation? Well, that one's the second term, and it's 8 is a sub 0 that I don't know, plus d that I don't know, but I do know the n minus 1. In this case, the n is 2, so 2 minus 1. So if I simplify these two down, I'll make them a different color. Let's make them red. This will be 8 equals a. I'm just going to call it a instead of a sub 0. They are kind of interchangeable in the formula sheet we have. Plus d times 1, which is just d, right? A plus d. And then the other one, this one, or right underneath it, is negative 12 equals a plus 3d. And then you can do that whole like elimination thing if you wanted to. Do you remember solving by elimination? Talked about it the other day. So I'm going to do opposite, opposite, opposite. Why did I do that? So that those two will eliminate each other when I add straight down. And then 2d is equal to 20. Whew, d equals 10.
It's negative 2D.
So d equals negative 10. Thank you. Okay. So I figured out d, but be careful that that's actually the question, because on the test they might not ask you for d. They might ask you for what's the fifth term. Would everybody please answer that question? What's the fifth term? Comma, next term would be, and what do you do with the d? Well, you put a negative 10 with the negative 12. Did you get negative 22? Raise your hand if you had that one right. Okay, good. Yes?
Wouldn't it be 8 minus 12?
Okay, I get how this part is confusing. If I'm going to get a and negative a to cancel each other, I have to add them together, right? So think of it as combining instead of adding or subtracting. And if I combine these two without changing any signs or anything, then they will make 0. So I'm going to combine these two without changing any signs or anything, so it actually is 20. So if that bothers you, I could go back to how it was in the first place, and I could say, at this moment, remember this blue mark right there where I put negative, negative, negative on everything? I didn't have to. I could just take those off, and then you can subtract each thing and go a minus a, 8 minus negative 12, and d minus 3. See what I'm saying? Okay. All right. So that's the hardest kind, and that's why I spent so much time on it, and maybe that means it's important, so pay attention. All right, on to the next one. I never even really finished number 2, but you should be able to with the help that I've given you. Look at this one. Should this one be able to add up to something? Yeah, because it's what? Because the numbers are doing what? getting smaller, but not just getting smaller. You can subtract 5 from something and it gets smaller. It's because the R value is between what? Between 0 and 1. All right. How can I tell that this isn't like just being subtracted each time? Well, because then this subtracted a lot more than this subtracted, so it's not just arithmetic. It's got to be geometric, and therefore it must have an R that's small, like between 0 and 1. And then you can use that formula for it, which you just learned and was on the second page of the notes. All right. Is this one? Well, wait a minute. This one's got positives and negatives. Doesn't that imply that R is negative? If R is negative, can you add these up? You don't think so? You can't have R be 0, but could R be negative? Like negative? Could R be negative 2? No, but what if R is negative a half? Maybe you'll have to give that one a try and see what you think. I'm not doing all your homework for you. You figure it out. Is there a key? Yes. Go look at the key. Okay. 12-minute warning, by the way. And we are in the homework, which is good. The only tip I wanted to give you about the lab that I gave the other class, and I thought it's only fair if I give you the same tip before we graded the lab, which will be tomorrow, is everybody act like... Oh, wait a minute. I better first, before we leave this, I better tell you which problems to do. All right, so here's the rest of the ones I want you to do. Everything on that page and everything on this page. And the piggy pink page. Okay, fine. I'll toss off the last one. You can skip number 3. All right. So then what's my tip for the lab? If you take out your lab right now, everybody take it out and act like I was about to grade it. One of the things I would ask you to show, or the person who's grading it is going to be like trying to find where you showed more than one way to solve for K. So let's say that your data was like this. You got like 100 M&Ms, then you rolled them and you got 52, and then you rolled them again, you got 25, and then you rolled them again. And let's say you had a freakishly like weird roll where it only went down 5, and it should have gone down like 12. Can weird things like that happen in the real world? Of course they can. So then, as you're going down and you're getting K values for each spot, just because your K comes out weird doesn't mean you did it wrong. It means that sometimes data comes out weird in the real world. Okay, that's why we average to get the answer. Now, this is the point I'm trying to make. For that K that you have on this chart right here, isn't there more than one way to find that K? There is. And that's the point. If you haven't showed that, how could you get that K value for some given spot on your chart? If you haven't showed 2 different ways to get that K value, then you're doing it wrong. And that means the answer would be different unless you have perfect data. If your data happened to be perfect, where you went from 100 to 50 to 25 to 12 and a half, good luck with that. You know what I'm saying? All right, so it's unlikely anybody has perfect data. If you had perfect data, then K would always be something, and I'm not going to say what it is, because that's one of the other things you're supposed to figure out at this lab, is what really was K supposed to be. All right, but if you can't see in your own lab where you showed 2 ways to find K, then you better clarify that, because you're going to be losing points, and I guarantee you you'll not get an A if you don't show more than 1 way to get K. If you got it 1 way, great, I'll give you some credit, but one of the hardest things in the lab is what's 2 different ways to get that answer, and they'll be slightly different. All right, that's all I have for you for today. See you tomorrow.